In the second tutorial on how to use the digital multimeter, we are going to be measuring resistances using the Circuits 1 parts list. So you should have for this activity your digital multimeter and probes and also the Circuit 1 part list. So we're going to be turning the digital multimeter to the white omega symbol, which means that we're measuring resistance in ohms. So when the probes are not connected to any circuit, it displays O.L, which means overload. It means that the resistance between these 2 points is so high that the digital multimeter can't read it. So let's measure some of these resistors. So what we need to do is we need to connect the probe and touch the metal on either side of the resistor. And you have to apply a little bit of force so that this can be held steady. So the first resistor that we read, it shows as 3.5 ohms. The nominal value was 3.3. So we can see that the resistor is close to the desired value, and the slight difference could be the manufacturing error of the part. So let's measure the next one, and we wait for it, and it says, I don't have a stable connection to the resistor. Try this again. Okay, it says 67 ohms, and the expected value was 68. The next one, we see is 460. We're going to skip the next one because that's similar. And we're just going to measure a few more of these resistances to see that they agree with what we expect. So this one is 0.983 kiloohms. So you'll notice that there was a K there. That means 1,000. So 0.983 kilo means 983. So 983 is close to this 1 kilo ohm, which is 1,000 ohms. Okay, I'm going to do 2 more. So I'm going to measure the 100 kilo ohm, and we can see it agrees very closely, 99.4. And then the last one, it's a little bit harder to hold. We see 0.979. So that agrees with the 1 mega ohm. So this shows how we can measure the resistances of the different parts. In case we accidentally lose which parts these are, we can either measure it or we can use the color code. I'm now going to talk about a few other functionalities that the digital multimeter has. The next one to look at is the continuity setting. So the continuity setting just checks to see, is there an electrical connection between the 2 probes? So if I touch it, it beeps so that I know that the probes are connected. So I can test, if I probe the same side of a resistor, it beeps because I have a connection. If I measure on opposite sides of the resistance is too high, so I can't actually tell that there's a connection. When I'm making measurements on circuits, I want to disconnect any batteries from my supply if I'm ever measuring in continuity mode or in resistance mode. When I want to measure voltages, then I do need my power supply connected, so my battery's connected to my circuit. Similarly, if I were to measure the AC or alternating current voltage, or if I was measuring current on milliamps or DC milliamps or DC 10 amps, I would be using the power supply.